Okay, so for distribution, we mentioned a binomial distribution or Poisson distribution or geometry distribution. So those distributions are discrete distribution, right? Okay. So for binomial distribution, so we have some trouble. Like if n is quite big, so like suppose n equal like 50, we have 50 questions, and so each question has 4 choices. So P 1/4 is the probability you can uh, pick a correct answer. Okay, so now we want to find those probability, like what is the chance that the number of your correct answer can be at least like 35, like this. So such a probability is not so easy uh, to calculation. Okay, so how to solve such a problem? So we say we use those binomial distribution close to a normal distribution. Okay, so like let's say, so here, so suppose it's 75 or 35, so we want to find this probability, right? Okay, so we say like we use a continuous distribution to close a discrete distribution. So such a distribution, so most important continuous distribution is normal distribution. So in general, we say we just changing this probability function px by a continuous function fx. So here px, so x can be only some discrete value. Like 1, okay, x can be 0, okay, x can be 1 or 2, like that. So this function just a continuous function fx. So here x can be any number. So this fx, we call this fx as a density function. Okay. So for this density function is just like probability. So at first we have this probability should be at least larger than 0. So all probability together is 1. So for continuous distribution, addition become integration, right? So the summation become integration. So in general, we say if a function fx satisfies those two conditions, then this fx is a density function for some random variable. Okay, so now for find a probability like this x, this random variable x is between a to b, so just become this integration, right? So like x can be any number, so x between a to b is the area for this part. So total area is 1. So this area become probability. Okay, or percentage. Now, what is the percentage in this area? Okay. Okay. So we say for those conditions, so we have many infinite those functions. Fx positive and total integration is 1. So we have many continuous distribution. Okay. So for distribution, we have expectation x or variance vx. So here they use the same formula. X addition or addition or summation become integration. So this is only difference. Summation, let's say, before we say this is xi multiply the probability xi for discrete situation. Right? We just add them up. So this becomes those summation become integration. So px become density function fx, so dx, right? So x uh, from uh, from so at just check all possible x, right? So we just put from in negative infinity to positive infinity. Okay. Okay. And so for the continuous distribution, because it involve an integration, so we defined those antiderivative, or like we from this integration. If integration from negative x, we just let this change, the upper bound change, then this is a function. So such a function we call cumulative distribution function, or sometimes uh, we say just distribution function, or density function, distribution function. Okay, so for continuous situation, so we have this. It's a derivative equal density function. But in here, fx is continuous. If fx is also continuous. If this is fx not continuous, discrete, or sometimes combined, some part is continuous, some part is discontinuous, then we cannot use derivative. We should use definition. Okay, so for one variable, so continuous situation, so we involve those integration. So for integration, actually, so we just need two formula for integration, like a polynomial function and exponential function, right? So polynomial function, so we just check each term, like part function x alpha dx equals this, and exponential function we just use x. So x integration just equal x. Okay, so this one is combined exponential function with polynomial function, like xk multiplied x. So those things, those integration, so need integration by parts. Okay, so we have this formula, like u dv equal uv minus v du. So here, that's for k is integer, we can do this integration by parts. So x not integer, we can integration by parts. X not k not integer, if k not integer, then such integration is so tough. X, let's say in general, x alpha x dx. So we call those integration as a gamma integration, gamma function. Gamma. Okay. Okay. And for integration, the typical way is use substitution to make things as simple as possible. Like for this one, so we only know this formula, right? The x dx I know. The x dx for this one, we can integrate out plus some constant. So for this one, so ideas we just let's say negative 2x, we just put this equal t. So this one become t, right? So those we call this a substitution. So if we change x to t, then we need to change everything in terms of t. So for example, so here upper bound x from 2 to 3, then t from when x equal 2, so from -4, right? And x equals 3, -6, right? And then we need to change dx. So what is dx? So we just change this, like x equal negative or half of t, right? Then dx equal negative half dt. So then we just put those coefficients outside, the negative half, and the low bound, upper bound, usually we just start from smaller one to bigger one. So this become half, so negative half, right? But if we change the order or change upper bound, low bound, then this is also a negative. So this become like -6 to -4 t dt, right? Okay, so this one is the same thing. Like let's say I only know x alpha, I only know x alpha dx, right? So this one, I use this. We let 1 plus x as t. So this become, so here's t2 or t negative 2, right? So upper bound, low bound, we also can change that. When x equals 2, t is 3. When x equals 3, t is 4. Then changing this dx to dt, so we find x equal t minus 1. So dx is just equal dt. So for this integration, I change this like 4, 3, so t negative 2 dt. For this one, so I know I can integrate out. Okay, so for one variable for continuous situation, many problems become a calculus problem, become integration. Like this one, we have this density function. Okay, and we want to find this probability that x is exceed 16. So here giving that, so this is conditional. So giving that means we just, for this part, totally is for those parts. So we want to find this probability. We say we want to find this x larger than 16 under this condition, under x larger than 8. Maybe I put it to here. Okay, we want to find this probability that x larger than 16, giving that x larger than 8. So this means like we saw here at the beginning, we say x is just from 0 to 20. So the question is we so we regard the total is not from 0 to 20, just from 8 to 20. So in this part, what is the chance? Like we say, this part count for this. This part from 16 to 20 count what the percentage for from 8 to 20. So for this conditional probabilities, we say the total is just this, x larger than 8, right? Then x larger than 8, then what is this part? X larger than 16. So we just x larger than 16. Okay. So now this just become those integration. X larger than a, we need to do some calculation. X larger than 16, we do some calculation, right? So let's consider x larger than some number. So let's say suppose t, because we put a t as 8 and 16, right? Or maybe we choose a. Yeah. T looks like variable. Yeah. X larger than a. What is chance? How to find the probability? So just from a to 20, and fx dx. Just this fx dx. Okay, and so this integration becomes so easy. So we take this outside, the constant outside, and so here we use substitution. We just say we regard this as a t. Okay, so t, then dt, so dt become negative. Yeah, but anyway, like so here, so a become 20 minus a, but 20 minus a is large, and then this becomes 0, right? So that's equal 0.05. So half of 20 minus a squared. Okay. Okay. So there's a probability. So it's just equal 20 minus 16. So that's 4 square. 20 minus 8. 20 minus 8, 12. 12 square. Okay, so we say such a problem is just completely a math problem, right? This probability problem is just a math problem, just the integration. Okay. Okay. So for this one, integration, those density function is this. So with absolute value, so we just need to check a positive part, negative part. So find expected value of x. So those just like that, right? X according to definition x, fx dx. This is expected value, but because fx is absolute value, or we can say this is piecewise defined function. So we need to check a piece by piece. Okay, so x values are from negative part, then absolute value become positive, so equals this, right? And positive part absolute value x is just x squared. So such things just like integration, easy. Okay. Okay, so there's a problem like so density function, we say we have the requirement that density function total probability equal 1. So here we the problem do not tell us that what the density function exactly is. It just tell us this density function is proportional to this. So this means fx equals this k times this. So we don't know k. So at the first, maybe we need to find this k. So how to find this k? Total probability is 1. Okay. So from here, we can find k. So we just make this integration equal 1. We can find k. So this problem just focus on those integration. Okay. So the integration use substitution, right? So 10 plus x, we just put this as t. Okay. Okay, then change everything in terms of t. Okay. So once we have this case, we have the exact this density function, then we can do anything. So here the question is, we want to find the probability that the lifetime from this part is less than 6. So this means we want to find x the less than 6. We want to find this probability, right? So this probability is just this integration. Okay. So once we know this k, so such an integration is easy. Okay. So those kind of problems just a little like a math problem. So here we want to find the probability. What is the probability that it is insured for less than 2? So we want to find the probability that x less than 2. So here we have a keyword giving that. So giving that means the conditional probability. We just check those. We already know this. So we just we say this home insurance, this x at least 1.5. Okay, so there's a probability. So there's a change. So here totally. So we started here 1.5. So we already know. So we just consider this part. So this is we forget. So x actually start from 1, right? But we forget this part because by now we already know this x is at least 1.5. So from this 1.5, we just check what is the chance is less than 2. So we just check this part count for how much for total. The total is this part, right? So there's a probability. So total is x larger than 1.5 total. And then we want to find this probability. So x less than 2. So this actually is x less than 2, but larger than 1.5, right? So, okay. So such a problem is just integration. How can do this integration? Or we know fx, then we can easily do those things. Okay. So those examples are just looks like pure mathematics. The probability problem, just like math problem, just integration problem. Okay. So as application, like insurance, as application, just in actual exam, we will have those kind of problem. We want to find expected value, but like expected values on the average, how much you can get from insurance, or how much you should pay. So how much premium you should pay, right? Those expected values are very important. But the insurance policy is quite complicated. We have deductible, right? Or we have copay, like those, right? Then we need to find the expectation or your premium under this policy. What the premium should be, or what the expected value should be. Okay, so we have deductible. Deductible means if $500 deductible means if the damage is less than $500, the company will not pay. You should pay by yourself, right? And the copay, like maybe copay means you need to pay 10% copay or 20% copay. So 20% insurance will pay 80%. So you should pay 20%. There's a copay. And the limit, so limit is like insurance. If you damage too high, like car insurance, the policy there will say the insurance will pay at most $20,000. If the damage is above $20,000, they will not pay. They are only at most they pay $20,000, right? So those are the limit. So the policy is we combine those things together. So we want to find under this policy, typical policy, what is expected value. Okay. Okay. So let's say, so here we say suppose x is loss, x is damage, x damage, x is loss. So let's say deductible C means like if x less than C, the payment. So here y is payment company will pay 0. If larger than C, they will pay this. So you should pay C, right? Then remaining one, insurance will pay. And copay, so there's a copay. Insurance, let's say, copay like you pay DX. The insurance will pay 1 month DX. Like if these 20%. So insurance will pay 80% and you will pay 20%. And the limit, so limit, we also can check this. We can put the limit is minimum of X and L. So if L is one like limit, L is things like 20,000. So if damage is less than 20,000, they will pay X. So this is like we only consider limit, like or do not consider deductible or copay. So here this is like the company will pay all. If the damage of the loss X larger than this L larger than $20,000, they just will pay $20,000. Okay. So the remaining ones they don't care. So this is why is the payment, insurance payment. So if we also consider deductible and copay, then the payment is they will pay X minus C, right? So this when C larger, when X larger than C, larger than copay. Not like copay. Larger than this deductible, so then they will pay. But they will not pay whole, they will pay 1 minus D. So this means like you, so you actually you should pay deductible C. Suppose the deductible is $500, so you should pay $500. And above $500, you still need to pay 20%. So insurance will pay 80%, right? Okay. So let's say so this policy put those things together, so it looks quite complicated. Okay. Okay. So typically expectation. So we will focus on like insurance, how much insurance should pay, like their expectation. So their expectation is just the premium. Okay. 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 So let's check some simple problem first, like minimum and maximum. Let's say y, like we have this x, and we have a new variable y or z. So we want to find the distribution for those new variable. Okay. So this y is we just take smaller one, x and 4. So when x is 1, we just take 1. X equal 2, just 2. So x equal 4, take y equal 4. X equal 5, y is still 4, right? So this y, this distribution, y equal 1, 2, 3, 4, right? So when x is 5, so we just take a smaller one. So this is probability for y. So when y equal 1, so when x equal 1, so x equal 1.01. So here x equal 2, so probability y equal 2 means x equal 2. So y equal 3 means x can be 3 when x equals 3, so y is 3, right? So when x equal 4, y equal 4. When x equal 5, y also equal 4. So y equal 4, so we can put these two cases together. So let's say 0.4, right? Okay. So for this z, we just pick a maximum. So if x is quite small, x equal 1, z equals 3. X equals 2, z equals 3. X equals 3, z equals 3. So x equals 4, z equals 4. X equals 5, z equals 5, right? So z equals 5 is when x equals 5. So there's a probability 0.3. And x equals 4, so z equals 4. So probability this. So all other things, x equals 1, 2, 3, z equals 3. So this is 0.6, right? So this is the distribution for z. So for discrete situation, so such a thing is easy, right? But for continuous situation, problem is a little bit difficult. So if we use those things, so x is continuous, but y is not continuous, right? If x is continuous, but y is continuous for some part, and discrete for some part. So y is, we say y follow mixed distribution. Okay, so let's say like so let's check this problem. Let's say suppose x has a density function thus. So x is from 0 to infinity. But if we define this as y like this, we say when x between 0 and 1, we define y as 0. When x is between 1 to 5, y equals this x. So when y is larger than 5, x larger than 5, y is 5. We can regard y as a payment, right? So 1 is deductible. If x is damage, right? If damage is less than 1, so they will pay 0. We are not pay. You should pay. And so when x, I'm sorry, so here when x between 1 to 5, they will pay all, but actually they should pay x minus 1, right? The insurance pay 1 x minus 1. So when x larger than 5, okay, they'll pay 5, or actually they will pay 4, right? If we consider deductible, so you always need to pay 1 for deductible, right? But anyway, like here, suppose like we can understand without this 1. So let me see. Let's okay. So this means like suppose they will pay 4 and they will pay 5. But anyway, like if y is like this, then we want to find expected value. So here, this distribution y is 0 means x between 0 to 1. So the probability between 0 to 1 is thus, right? integration. So when x between 1 to 5, so this x and y is same. The density function is just the fx. So when x larger than 5, so the y is 5. So the probability is this. So this distribution, like this part is continuous. There's 2 points, so we say the distribution like that. X can be 0 and can be 1 to 5. From 1 to 5, this is like this, right? And larger than 5, the density is x is larger than 5. X larger than y always equal 5. So here there's a point. Y cannot be 6, right? Y 5 is that. Okay, so find expected value. Expectation is y equal y multiplies the probability, right? So y is 0 multiplies the probability. So plus y is x multiplies the probability. So here addition become integration, right? So 1 to 5. So here y is 5 multiplies probability is that. Okay, so such a problem is a mixed distribution. Okay, so once you understand, so then this by now, so the things become math problem. Okay, so now so this problem is just from insurance company, or this is just like actually exam 1's problem. So it says like we have this x is damage or loss. This loss have this density function, but the payment insurance pay not pay all of x. It has a deductible C. Okay, so here we want to find C. So this like with this deductible, then the insurance, let's say the insurance payment is less than 0.5 is equals this. We wanted to make sure like the payment is less than, let's say payment less than 0.5. We prefer like if we have deductible, things this probability becomes smaller, right? So if we know there's a probability, we want to find this deductible. Okay. Okay. So let's say so at the first we need to find the y. So what's the y? Y equal x minus c, right? When x larger than c, this thing less than c is 0. Okay. Okay. So so now we want to find the probability. Let's say so how can we calculate the probability? So y payment less than 0.5. Okay, here the last thing. So here we have 2 cases, like if x, so let's say like x, this is for x, so damage from 0 to let's say this damage x is 0 to 1. Okay, and the density function we already know the 2x. x 0 to 1. So we set deductible c here. So if x from 0 to c, y equals 0. So, so this is definitely less than 0.5, right? Okay, so this is 0 plus. So if x here larger than c, so there will pay. So this become payment is x minus c, right? So this payment less than 0.5. Okay. So this probability is thus. So we want to find c. Okay. Okay. So y equals 0. So y equals 0 meaning this probability x from 0 to c to x dx, right? Okay. And for this part, so here actually we have a condition x is larger than c. So from c to x. Okay. Okay. So x. Oh, this is actually this probability. Let's say. So x less than 0.5 plus c. But this x actually is larger than c, right? Okay, so this probability, this by now become math problem, integration problem. So we have like 2x dx equal just like x squared. If we integrate out, this equal x squared, right? So this equal c squared plus, so this integration, this equal 0.5. So if let's say from a to b to x dx, so this equal just b squared minus a squared, right? So this equal c squared minus c squared. This equal 0.5 plus c squared. Then we let this equal 0.64, so we can find c. So we have similar problems, but once I understand those things, so this probability, this problem quite the same. So let's say that here, we want to find what is the mean of the manufacturer's annual losses not paid by insurance company. So we want to find, let's say, we want to find this mean y. This y is not paid. Okay, so let's say let's check. So here x this loss follow this distribution has this density function. Okay. Okay. So the insurance policies annual deductible of 2. So annual deductible is 2. So let's say. So let's say this x loss is at least 0.6, right? Okay. Always have some loss. Okay. And so actually start from here. X larger than 0.6. So deductible is 2, so we put here the 2. So if x here insurance will pay not pay. Insurance pays zeros not pay. So this is insurance will not pay. And above 2, insurance will pay limit will pay source, but so you still need to pay $2, right? So here not pays 2, we can say here not pays X, right? So below the deductible, so insurance will not pay what? X, right? Depends on the damage. Okay, so not pay, so this Y is just like that. Y is equal X, when X between 0.6 to 2, or Y equal 2, right? When X larger than 2. Okay, so once we understand this, then such a problem become easy, right? So what is Y? Y equal, so Y multiplies the density function of probability. So Y, so here between 0 to 2, this Y not pays X. Then density function fx dx. So X from 0.6 to 2. Okay, so plus, so X larger than 2 from 2 to infinity, so not pays 2, right? And probability is this density function fx, right? Okay, so now this becomes this is math problem. Just plug in here. So this is just a coefficient. Okay, just so this function, so just like x negative 3.5, right? And some constant. So there's a constant k, 2.5 multiplied 0.6, 2.5 is power. So there's k, just to make this function is a density function, or total probability is 1. Okay. Okay, so those kinds of problem, so what is the same? Okay, like here we want to find expected value of benefit paid under this insurance policy. So here we want to find Y. So what is Y? Y is benefit or payment paid. Y is insurance payment. Okay. Oh, I'm sorry. We cannot use Y, yeah, because we already have Y. So suppose this is Z, okay, like Z. We just changing the name, okay. Okay, so let's say like the loss Y for this distribution, and we want to find oh, so find this Z payment. So payment, there's a payment. Okay, so loss from 1 to infinity. Okay, but this benefit has benefit limited 10. So above 10 they will pay 10, right? Above 10 they will pay 10. So below 10 they will pay whole loss. So this equal, we say this equals, we also can say loss Y is here, they will pay the Y. So average is Y if Y dy. So when Y is 1 to 10, so when Y above 10, Y is here, Y here, or here. So above 10, there will pay, so from 10 to infinity, there will pay 10, right? And So for such a problem, let's say such a problem is looks like quite complicated. Uh, so the car, let's say, car was thus $15,000. So policy is 1,000 deductible. So during the policy year, there is also so much chance, 0.004 chance that partially damaged, and so much chance totally damaged. So if totally damage happened, how much insurance will pay? So pay this, pay whole, but you need to pay a deductible. So actually they will pay $14,000, right? So $1,000 they will not pay. So if for have a partial damage, so partial damage, so how much damage? How much damage? It depends, right? Depends the situation. So how much damage? So could it be from 0 to 15,000? Okay, so the probability, the density function like this. Okay, so what we want to find expected claim payment. Just find we like we want to find is y. This y is payment paid by insurance company, right? So here, this question we have like a discrete situation, like a total damage. This is they will pay so much, but for this like a partial damage, this number of total damage, we know the loss is 15,000. This is fixed. But for partial damage, the number we don't know can change, right? So this is landing variable. So this x can change. Could it be very small? Could it be very large? The total is 15, right? Yeah. Okay. So we just check the other case like okay. So a total damage, so they will pay that. And partial damage is partial. So we have partial damage will damages x, and the payment is let's say x minus. We also can use this notation, x minus 1,000 maximum. So if x is less than 1,000, the payment is 0. Right? We just take like a we can use this notation, but anyway we understand this. Like x large is less than 1,000, they just pay 0. So if x larger than 1,000, they will pay x minus 1,000. Okay. Okay. So here we have two cases: partial damage, total damage, right? So there's y. So we also check two cases: total damage probability 0.002. So and payment thus. And the partial damage probability 0.004, but the number of damage, the number of payment is like x minus 1,000. So we need to check like equal payment to the x minus 1,000 and multiply density function fx dx, right? And so here x is at least 1,000, yeah, from 1,000 to 15,000. Okay. Okay. Oh, so by the way, this x is not from 1000 to 15. X is from 0 to 15. So we just changing this 1000 to be 1. So here changing this 1000 to be 1, but here also changing 1000 to be 1. So we just use 1000. We just use 1000 as a unit. Okay. Okay. So we skip this problem. Yeah. Okay. The quite the same. Okay. Okay. So now let's consider this problem determine values of y. So we can change like we know x, but y is not exactly equal x. Y is adjusted or modified for x. Okay. So let's say that here for x has this density function x from 0 to 5. So this x, we can say this is this age of this machine, or machine, how long this machine can work. Okay, so maybe from 0, like at most 5 years. Okay, so let's say, so the company like will not use very old machine. So it, let's say, it will be replaced at failure or age 4. So if the machine not work, so replace immediately, right? If this machine still can work but too old, we still need to replace, right? So this is why, so let's say x. So here x, we can say this is lifetime, or yeah, the age of the machine. So x can be here 1 year or 1.5 year, or like here. So replace is what is replace? So we can use this notation: replace y, replace time, y equal when x is from 0 to 4, y equal x, right? So when x larger than, like between, like let's say x is between 0 or 5 to 4, this y equal 4. So at this time we'll replace. Okay. So we can find expected y or variance of y. We want to find vy. So vy equal, so we can use this notation, this formula, equal ey squared minus ey squared. Okay. So what is ey squared? So how can find ey squared? So let's say, how can find this ey squared? So this equal ey squared is y squared fy, right? dy. Okay. So let's say, what is y squared? Oh, what is y squared? So we have two cases. Sometimes you call x squared. So then the function, just the probability is just fx, probability is 1 over 5 gx. Okay, so in this case, when x from 0 to 4, okay, and plus this y can be 4, so equal 4 squared. And the probability is when x between 4 to 5. Okay, so this is ey squared. Okay, so so once we understand it, then what is y? Y is just the y and probability like density function. So this you probably also just check two cases. So y equal x. So probability is 1/5 dx of x between 0 to 4. So y can be 4. Y can be 4. So probability is when x between 4 to 5. So 4 to 5 dx, fx dx, fx 1/5 dx. Okay. So those are just the so those problems just like mathematics math problems plus like involve those like so we can regard those just we say those just like variable transfer like variable transformation or variable substitution. But this is not like substitution or transformation, just like we say modified. Like we know x, but y is not exactly equal x under this condition, under that condition, right? So we say those are just adjusted variable from the given variable x. So such a problem is very common in insurance policy or in actual exam. Okay. Okay. Oh, I cannot finish those things in 1 hour. So whole notes in 1 hour. So maybe we have to stop here. Uh, I have to keep this the length of the videos about 1 hour. If too long, then I have some trouble for upload. So we can stop here.